Thank you. The clicker is this one. Thanks everyone for showing up. My name is Chad Smithson from Trusscore. And yeah, I'm going to be talking to you about what we call digital paint at Trusscore. So very quickly, here we go. So what's Trusscore? We're a rigid PVC manufacturing company. Our flagship product is in the bottom right of the image here. It's a wall and ceiling board panel. So it goes directly onto your walls, right onto the studs instead of drywall. So we're a replacement for drywall. We also make the trim as well as slat wall that you can see in the image here. So you can put hooks and things to hang product. We have two manufacturing facilities. They're both in Canada. One is in Ontario. The other is in Alberta. And then we have our R&D facility, which is in Kitchener, Ontario. This is really close to the University of Waterloo, if anyone's familiar with it. So one big thing, we got a new CEO about 5 years ago, and his big focus was that we wanted Trusscore to be a material science company that was focused on sustainable building materials. So he wants to change the building industry. It has been pretty stagnant for many years, so we want to help evolve it. So we do some material science that would be related to PVC, so things like making compounding, so this includes fusion time, fusion torque, degradation. We also do a lot of fire performance. Our products are meant to go into your homes, so we have to pass a lot of fire safety. PVC doesn't burn very well, but it does make a lot of smoke, so we have to put a lot of smoke suppression into our products. Here's just a quick look at our factories, or one of them at least. So we have, I believe, 9 extrusion lines in this factory. You can see all the piping where we pull the compound from the silos. It gets sent down to the extruder where it's melted. It then goes through a die, shaped, formed, and becomes your plastic product. So from all this, there's probably something you've noticed through all of it. It is that our product is white. It gets used in lots of locations, but it is white. And so this is where digital paint comes into play. We could go into the factory and put colorant into the pigment, and you can make all of your PVC compound whatever color you want. However, our product is very large, and stocking this with all of our suppliers would be very cumbersome. You could imagine 25 unique colors, these large panels. It's not something people want to do. So we want to find alternative options to this. One early thing we tried was to use LEDs. We made semi-transparent panels, and we put LEDs behind them, so you can see that it works. You can actually see the dye lines when it comes out of the extrusion process. It's interesting, but I don't know how many of you would actually want this in your house where your walls are glowing at you all the time. And so we know this too. So this is where digital paint comes into play. So what is digital paint? The idea is that there's a thin film put onto the front face of the Trusscore panel. You put this onto your walls, and then from a simple app in your phone, you can just pick which color you want your wall to change, and it will then change immediately. So this is achieved through electrochromic technology. Electrochromics have been well known for a long time. Really simply, how they work, you have a transparent conductor layer 8. You also have another conductor layer 4. And between them, you have your electrochromic, an electrolyte, and an ion storage material. So when you apply a voltage between layers 8 and 4, you're going to oxidize or reduce the electrochromic. This will cause it to change color. Ours go from colored to transparent. And then you move an ion across the electrolyte, and it's held in place by the ion storage layer. You can reverse the bias by just reversing the voltage. This will make the whole system change back to its original state. So the plan for us over the past few years, this has been our journey, is that we were starting in the material science to make the materials, the electrochromic materials that we want, specifically the colors cyan, yellow, and magenta for additive color or subtractive color mixing. We then go into formulation, lab scale printing, and analysis of the material, so electrochemistry and color analysis. And then we move on to roll-to-roll printing, and eventually laminate that onto the Trusscore panel. So early on, how did we choose what materials we were going to work with? There were 3 main categories we could choose from: small molecule, polymeric, or metal oxides. We worked a bit with small molecule, but we did find that they degraded quickly, or often had quick degradation, as well as a few other problems. Metal oxides work well, but they do have limited color options to them. There's not as many things we can do. We also didn't want to put heavy metals into all of our walls that would be in our homes. So we focused on polymeric materials. This image in the middle is not our work. This is John Reynolds' work, but it was a great starting point for us to know that you can tune polymers to whatever color you want. And so first big focus for us was to make them green solvent soluble. We want to run these on production lines. We can't have them in chloroform or other nasty solvents like that. So we were targeting waters, alcohols, esters, things of that nature. Here's some simple beginnings for us.